Hello everybody, my name is Richard Crosby. I'm the Director of Seismic Group and I've been passionate about improving productivity in the construction industry for about 10 years now, where we've been developing Seismic. The Seismic platform is a cross-sector construction platform of reconfigurable standard components suitable for schools, offices, retail, residential, hospitals and many more. It complies with the product platform rulebook. Having built a prototype, it's now used as a demonstrator building, which is housed at the BRE Innovation Park. We are developing and putting the Seismic platform out into public use. So today I'm going to talk about why Seismic, product platforms as defined by government, and it's coming to everybody. The Seismic platform itself, what we've achieved so far with the Seismic platform, and also where it could go from here. So Seismic Group has been established to be a platform provider. We are not project managers or contractors or designers. We are putting out to the market, and this is following 9 years and almost £30 million worth of research and development to deliver. It was developed off the back of an original collaboration of key individuals funded by UKRI. It was led by ourselves and the previous guys, together with Tata Steel, Algeco, McAvoy Group, the Manufacturing Technology Centre, the National Composite Centre, and the Active Building Swansea University. So why Seismic? Seismic was developed as a project originally, following on from the 2013 requirements of government when they laid down the gauntlet to industry to improve cost, delivery, emissions and exports. So why Seismic? Well, we've had the Eakin report, the Latham report, the Farmer report, etc., all saying similar things over the years. So why have things not moved on and changed over those years? Well, we've got to start looking and addressing those before we could start looking at changing things going forward. It is worth to note that our primary components and materials we've been using in steel for hundreds, if not longer than that, years ago. We use steel, we use timber and cement-based products. So are we just regurgitating how much of those three holy grail materials that we are using? Should we be not looking at the past to see how we can then improve going forward? After all, the Romans invented concrete. We've had precast concrete around since pre-war days, and we've done some pretty amazing things since then. Let's not forget the good work that has been done. So we've come on and we're looking at the good work that does happen across different sectors. Initially, we started looking at the volumetric process, and we thought the site efficiency of that was pretty great, but we were disappointed by the productivity in the factory, and also recognising risk problems as occur with volumetric, companies going bust. The requirement to have to engage with them early, possibly before planning, before costs are known, which is really putting and hindering the market. So we wanted to try and address those. So we wanted to look at, we wanted to take that site efficiency of volumetric, but also look at how panelized, for example, manages to be more productive in the factory. But also look at the risk profile, the interoperability of components and variability of the supply chain that the traditional industry has. We also look beyond our own industry, construction industry, look at aerospace and how they assemble buildings and the methodology that they used, as well as digital technologies and how the business models from digital technologies work. But crucially, and one that we always can't shy away from, is that of economic variability, the flows of the requirement. And those that have presented construction into this form that it is at the moment, which is lots of stopping and starting and variance in the market. One thing that we're not going to touch on is car platforms. We've all heard enough about car platforms and how great the automotive industry is. I'm going to tell you here now why it's not suitable for the construction industry. And VW, as an example, spent 60 billion developing their latest EV platform. Now, this is a company that used to producing platforms to do that. The construction sector has far more variability than the car industry is. It has far less visibility of the supply chain and future workloads, not to mention profit margins. Also, platforms have been around for a little while now, and in fact, the construction playbook, which was updated in July of last year, is actually telling everybody in the market now, from a public sector perspective, which is now moving into the private sector as well, is that we should be using them. And here's if you haven't read the construction playbook, please do. Here's a bit of a snippet of what it says that it should be doing to do that. But of course, lots of people are still wondering what platforms are. So the government have also produced the product platform rulebook, association with the Construction Innovation Hub that produced this. And that gives 8 key rules of what a platform needs to do. We believe that the Seismic platform is the only one which is market ready and meets every requirement of that platform rulebook. So we have to, but crucially as part of that, a platform needs to be open to the entire market. As we've already touched on with cars, the key issue with a platform is that everybody has to take part to do this. And this is why we come in as a platform provider, because we license out information to the market and like to use so that the whole market can then develop new components to meet the unstoppable variability within the market of themselves. And it allows contractors and designers to develop their own versions of this from the base that we've started. In doing so, we've produced a series of interoperable components that work on a standard system. This is a platform that's a series of flute roof cassettes, floor cassettes, ceiling cassettes, varieties and specifications, which the market can develop themselves as products as they see volume that comes out of it. All our current components are currently based on LGSF, light gauge steel frame, with a cassette chassis, with hot roll posts holding these things in there. It can be assembled in any way. It is originally based on the volumetric processes because of the site efficiency that we taken on, but it actually can be assembled as a bag of bits directly onto site, or more practically so, to do it as a 2D cassette version, depending on the site. So it's a one platform that can be assembled in numerous different ways. It's not intended to be the whole of a building. It is just as much as a building as it needs to be, and it gives efficiency there. We use standard bay widths of 3.6 meters to give an optimum layout for buildings, but they can vary as a true platform should, between 2.4 and 4.2. They can be assembled by any manufacturers, multiple manufacturers, either in parallel or with one at all. So taking back to the reference that we made to the aerospace industry, where a Boeing Dreamliner maybe have the wings made in Singapore and the carriage in France and so on. We can do the same thing. In fact, we've actually tested this and proven it by having components made in Wales, in Scotland, and in Northern Ireland and in England, and assembled into one project on site all concurrently. And when you do that, that just basically hacks the critical path of any program into many pieces, and you've got components to really speed things up. The key part of it is open for use for all tier 1 contractors and supply chains, designers to be involved with to do this. So it allows a true collaborative way of working with interoperability assemblies. So why should we do this? Well, really, if we look at where we were trying to get to against the industrial challenge that was laid down in 2025 targets, we've actually managed to achieve 47% better value based on an assessment that's been done with the value toolkit. It's also, we've proven to be at least 75% faster than traditional construction. And actually, what was more surprising than anything, because we didn't really target this initially, to be honest, was that we ended up being 70% lower in carbon than traditional construction. These were all independently assessed, and I'll address that in a little bit more detail. But really, there is some big numbers to be had to do this. And but don't take our word for it. You can go and visit the demonstrator building that we have, which is at the BRE, as I mentioned earlier, and an example of where we've done, and we show people how we've done it. So I'm just giving you a taster of this. Basically, most of the carbon has been done, reduction has been done through its disassembly and reuse and beyond life. We took a long look at how we do this. And it gives lots of benefits in different ways. If it's easy to assemble, it's easy to disassemble in terms of how you use that. And because of the way we were doing this, it allowed us to tighten tolerances up, really tighten tolerances up. Now we've got down to plus or minus 2 mil, which is across a 10-meter cassette, diagonally across, which is pretty good for the construction industry as a whole. When you compare some traditional ways of working, are looking at 20 mil across a similar sort of distance, if not less. But because most buildings are demolished, because their purpose or the need for the building changes, we feel we should be designing for adaptation and reuse beyond the life of the building, so that we can reuse different components and upgrade as necessary, and rather than just shuffling the figures around between whether it's steel, concrete, or timber. The tolerances really does open up different opportunities as well, which I'll bring up to later. So really, what are the next steps from where we go from here? Well, as more and more people get involved with working with us as Seismic partners, developing the kit of components that we have, it really does think about where we can go, particularly on the reuse and the carbon piece, which is obviously becoming more prevalent. If we can reuse components, we can put more money into those components to create additional quality, to allow them to last longer and reused irrespective of their location. That opens up different ways of funding buildings. We're not just funding the building that's fixed on its site. We can fund components. Think about that, how that might bring changes to the market if you've still got value in your components that you use. Additionally, the tight tolerances that we believe we can get tighter on this opens up different ways of different material use. So we're going away from that timber and concrete, particular where you struggle to get the tolerances in, and we can start looking at new tolerances. Tolerances we tend to use, particularly concrete-based products, because they are cheap and easy to reflex and reuse. But if you can cut new materials down to site exactly to tolerance, it brings these new materials into play, and that's the really exciting piece that I think we've got in construction: new materials going forward. So many thanks for listening to me. If you're interested in getting involved in the Seismic platform, please don't hesitate to contact me or get in touch via our website, which is at www.seismicgroup.co. Thank you very much.